Hello and welcome to your algebra recording for the week of August 29th. We're also, I should put up here, in week 3. We're also in week 3. So when you go to do your assignments this week, you should be looking for that week of August 29th and week 3 folder. Alrighty, so we're going to start with some warm-up, reviewing what we did last week, where we learned how to solve for absolute value functions. So at this time, I want to make sure that you've got your math notebook out and you're ready to take notes. And I would also like for you to try this warm-up problem in your math notebook. There's actually 2. So I would like for you to click pause at this time and make sure you've got your math notebook out. Try these in your math notebook, and when you're ready to check your work with mine, go ahead and click play. So go ahead and click pause now and try those warm-up problems. All right, so we are solving for the absolute value of 2x minus 4 equals 8, and we want to find the value of x. And we do have our absolute bars here. There is nothing on the outside of our absolute bars, so that means that we've got the equation within the absolute value bars already isolated. So we can go ahead to the next step, which is where we're going to write 2 equations. We're going to write 2x minus 4 equals 8. And we're also going to solve the equation 2x minus 4 equals negative 8. Because remember, those absolute value bars tell us the distance on the number line from 8 in both directions. So we can have the negative 8 to 0 would be 8. Units, as well as from 0 to 8 on the positive side would be 8 units. So we're going to have 2 equations that we're going to solve for, and both of our values, and I wrote up there, will be the values of x. There's going to be 2 different values that will work. So to solve for x on this equation over here on the left, we're going to start by adding 4 to both sides. We're going to start by adding 4 to both sides. Then we have 2x equals 12. And then we're going to divide each side by 2. And we get x equals 12 divided by 2 is 6. So one of our possible values of x is 6. Now we're going to do the other equation over here on the right where we've got it set equal to negative 8. And we're going to start the same way here by adding 4 to both sides. And then we have 2x equals negative 8. That should be the equal sign. Negative 8 plus 4 is negative 4. And then we're going to divide each side by 2, divide each side by 2, and we get x equals negative 4 divided by positive 2 is negative 2. So these are both our answers. X can equal 6. And x can equal negative 2. So there's 2 different answers that we've got. Moving on to the second equation. So now we look and our absolute value of x plus 2 is not isolated because we've got a 4 out front. We've got 4 times. So the first step is that we need to isolate the equation that's in the absolute value bars. So since we've got 4 being multiplied by the absolute value of x plus 2, we're going to start by dividing each side by 4. And then we're left with the absolute value of x plus 2 equals 12 divided by 4 is 3. So now we've got our the equation that's in the absolute value bars isolated. So now we can write our 2 equations that we're going to solve for. X plus 2 equals 3, and we're going to have x plus 2 equals negative 3. Remember, you always change it to a negative and positive version of what the equation is set equal to. Start by subtracting each side by 2. X equals 3 minus 2 is 1. And then over here, we're just going to subtract 2 from both sides, and we get x equals negative 5. So remember, these are both our answers, and we need both to get full credit. We need both to get full credit. All right, I'm going to go on to the next slide, so if you need more time here, go ahead and click pause. So this week, we're moving on to Unit 1, Session 3, which is all about inequalities, and then Unit 1, Session 4, which is about compound inequalities. So 2 sessions this week. Just some reminders as we get going here to make sure you're checking your grades. Not only to see what your overall grade is, but you need to be clicking on the assignments that are graded to actually open it up and see what you missed. So I leave lots of feedback within your assignments, so make sure you're taking the time to see what you missed and my feedback. And my feedback will help you to retake low-scoring assignments. Remember, you can redo low-scoring assignments, and you should be. So if you do choose to redo an assignment, just make sure you message me after you redo that assignment so that I know to grade it. And then last but not least, just a friendly reminder, make sure you're taking notes while you watch the recording and as you go through your lessons in Schoology each week. Make sure you've got a math notebook and you're actually using it to take notes as you're going through the lessons and try and practice problems as well. All right, so let's start learning about equalities. So this should be a quick review for you. So remember, inequalities are what we use when something's not exactly equal. When we've got equations, we set one side equal to the other. So when we have equations that are not exactly equal, we use inequalities. And here are the different inequalities that we can have. Greater than, which, let's put up what that looks like. The inequality for greater than goes in this direction. Less than goes in this direction. We always read them from right to left, just like a book. And then sometimes we have when greater than or equal to, where we put one line under it, and then less than or equal to when we put one line under it. So that should be a quick review of the inequality signs. So keywords, some keywords and what inequalities we use with those keywords. This is a great chart for you to jot down if you need a reminder about these. So when you see at least, when you're reading through a problem and it says at least, this is going to mean greater than or equal to. When you see no more than, it's going to mean less than or equal to. And then more than or less than is pretty straightforward. But these two I wanted to remind everybody about at least and no more and which signs we use for them. So for example, you must be at least 40 pounds to ride on a roller coaster. So we would say at least. That means that somebody would have to be greater than or equal to 40 pounds. They could be 40 pounds, they could be 40.5, they could be 42, but they have to be at least 40 pounds. So that's the inequality that we would use. Moving on, so let's write some inequalities. And if you want, you could start by clicking this. This might be a review for you, and you might want to just try these on your own first. So if you want to, go ahead and click pause and try these on your own. And then check your work with mine. All right, so the first one says Ellie must score at least. We see that keyword at least an 85 on her test to keep her B average in the class. So what would we use? Which inequality for at least? Well, she needs to score greater than or equal to 85%. The next one, a number minus, so I could put the x here. By the way, I should have said that and let x represent the score she needs to have on her next test. So the next one says a number, so it's an unknown, so I'm going to put x to represent the unknown number, minus 2, so I'm going to subtract from that number minus 2, is greater than, so I'm just going to use the greater than inequality 4. And then we could actually solve this, but we're not going to. I just wanted us to write inequalities. Let's look at the next one. See if you can do this one on your own. Kate has no more than $20 to spend on groceries. Go ahead and see if you can write an inequality to represent that statement. So no more than that's going to be less than or equal to. So the amount of money that she has, I'm going to represent with X. She has no more than $20 to spend on groceries, so she can spend $20 or less. So we're going to use the less than or equal sign. Going to go on to the next slide. So graphing inequalities on a number line. So if we wanted to graph an inequality on a number line, I'm going to go over this. This should be review. So anytime you have greater than or less than, if you have greater than or less than, you're going to use an open circle on a number line. You're going to use an open circle on a number line to show it does not include that number. That open line shows that it does not include that number. It's greater than or less than. We use a closed circle when we have greater than or equal to because it includes that number. It's going to actually include that number. And then we would shade to the left if the inequality sign is less than or equal to or less than. And then we would shade to the right if it's greater than that number, greater than or equal to. So let's do some graphing on some number lines. All right, so we want to graph that. I'm going to change this. Let's do X is greater than 5. And then I'm going to add that one here and this one here. So just X is greater than 5. X is greater than 5. So the first thing that we want to do is change my stuff here. All right, is we want to find 5 on our number line. So it's positive 5. So here's 5. Now, do we want an open or closed circle? So it's just X is greater than. There's no greater than or equal to. So it's just greater than. So we're going to have an open circle. Now we have to decide, are we going to shade to the left or the right? Well, since it says greater than, that means we shade to the right. So this could be all the numbers that could be included. Anything that's greater than 5. It can't include 5, but it can be like 5.02, 5.05, 6, 7, 8, 9, 10, anything greater than 5. All right, so pretty easy, right? So let's look at the next one. X is greater than or equal to -2. So first step is find -2 on our number lines right here. And are we going to do an open or closed circle? So because it is greater than or equal to, we're going to do a closed circle. Then we decide, do we shade to the right or left? It's greater than, so we're going to shade to the right again. It's greater than. So let's see if you can do the last one on your own. So graph X is greater than or equal to 4. So go ahead and see if you can do that one on your own. So go ahead and click pause. All right, so we find 4. It's, you know what? This one is also greater. I didn't have any less than. I should have done the less than. So we're going to do a closed circle, and we will shade to the right again because it's greater than. If it was less than, we would be shading to the left, but we didn't have any of those. I'm going to move to the next slide, so if you need more time, go ahead and click pause. All right, so solving inequalities. So solving for inequalities, most of the time we're going to go about it the same way we would an equation, where we have an equal sign, but now we've got an inequality sign. So we're going to do it the same way. The only big difference is this step right here. When you're solving for the x variable, you divide or multiply by a negative number, you have to reverse the direction of the inequality sign. That's the only difference here of solving inequalities versus solving regular equations. So let's go ahead and solve some inequalities. We're going to do it the same way we did, like we said. So we're solving for x, we're getting x all alone, so we're going to subtract 4 from each side. So now I would have x is greater than 6, and I'm done. That's my final answer. Pretty easy, right? So here's where the second problem, this is where that rule comes in place. So I've got -3x x, which is negative 3 times x, is less than 15. So how am I going to solve for x? X is being multiplied by negative 3. So here, this is where that rule, it says if you multiply or divide by a negative number, we need to reverse the direction of an inequality sign. So I'm going to divide each side by negative 3, and when I do that, instead of saying x is less than, now I'm going to change the direction so it's greater than. 15 divided by negative 3 is negative 5. So that's the big takeaway here is this second rule. If you're solving for an equation, solving for a variable, and you have to divide or multiply by a negative number, you need to reverse the direction of the inequality symbol. That's it. Moving on to the next slide. Let's try 2 and 3. So I want you guys to try 2 and 3 on your own. So go ahead and click pause and try these on your own, and then I want you to check your work with mine. So this number 2, we've got negative 4x is greater than 16. So how do I solve for x? It's being multiplied by negative 4, so I'm going to divide each side by negative 4. What do we do to the inequality side when we divide by a negative number? We switch the direction of it. So 16 divided by negative 4 is negative 4. So now we've got our answer of x is less than negative 4. Moving on to that last one. Let's change colors so we don't get mixed up. So this is y divided by 2 is less than negative 6. So y is being divided by 2. Y is being divided by 2. So the opposite of dividing is multiplying. So to solve here, I'm going to multiply each side by 2. So I multiplied by positive 2, so I do not need to change the direction of my inequality sign. Negative 6 times positive 2 is negative 12. So the answer is going to be y is less than negative 12. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. And that's it. So just a quick reminder of inequalities. So now is the time for you to get your 10 points for watching the recording, but remember you have to complete the key phrase assignment. So let me put up the key phrase. And just a heads up, I did not go over everything you will see this week, but this will give you a good foundation to go into the lessons for this week. So the key phrase question for this week is, and remember we're in week 3, by the way, this is week 3, so make sure the date of the key phrase assignment matches this date, week of August 28th or week 3. Make sure the date of the key phrase assignment is also the week of August 29th or week 3. So the question you need to answer is, when solving inequalities, when will you reverse the direction of the inequality sign? So when would you reverse the direction of the inequality sign? The directions to complete the key phrase assignment are right here. So first you're going to log into your algebra class. You'll click on the materials tab. You'll see the folder weekly recordings and key phrase assignments. And then again, make sure you look for that correctly labeled key phrase assignment date. The date of this recording should match that. Answer that question, click submit, and you are done. So let me know if you have any questions as you're working through this week. Have a fantastic rest of your week, everyone.